was an error, you needed to explain what the error was. If there wasn't, you just needed to say no error. And then if there was an error, you needed to correct the math. Okay? So first of all, is there an error? Yes, okay, there is an error. Alright? What is the error? And anyone can say anything. What went wrong here? Say it a little louder.
Angle 1 plus 80 plus 50 equals 80.
Right, that doesn't work, right? Okay, if angle 1 were inside the triangle, would they be correct? Yes, okay, but this angle 1 is outside the triangle, so they did not use this exterior angle theorem correctly. Okay? So something along those lines is what you need to have. That they did not use the exterior angle theorem correctly because angle 1 is outside the triangle. Something along those lines. Okay? I cannot say that these add up to 180 because that angle 1 is outside the triangle. Okay? So where do I need to go to correct this? What can I write as an equation to correct it? That's what they have.
No, we talked about
And we're trying to find angle 1.
Oh,
That's what we're trying to do. We're trying to find angle 1. Bryson?
angle 1 equals 80 plus 50.
There you go. Okay. Angle 1 equals 80 plus 50. So remember, that's your exterior angle theorem that we talked about yesterday. The two opposite interior angles, if I add them up, I get my exterior angle. Okay, that's what we talked about yesterday. Okay, so what does that make the measure of angle 1 then? 130. Okay, so that's the work-ish that you need to have in order to get that full credit. Okay, so you need a picture, some sort of explanation on why there's an error, and then the correct math. Okay, once you have that, if you will submit your bell ringers on Schoology, please. If you cannot submit them on Schoology, write them over here. Please make sure you have your name on them. And then just be sure you've got all 4. And just a reminder that I will have your tests graded by Monday. Yeah. Alright, I do have 2 bell ringers already with that name. Either of these look like yours. You can put your name on. On plain. Got 1 more bell ringer without a name on it. That you don't. Alright, so today we are talking about triangle congruence, okay, and that's kind of where we're going to stay for the remainder of this unit, if you want to call it that. Okay, so sticking with triangles, and there are 5 important theorems that we're going to talk about. Okay, today we'll talk about 2 of them. On Monday we'll talk about the other 3. Tuesday will probably be a practice day, and then on Wednesday we'll tie it all together. Okay. All right. So the first thing we need to talk about is something that is a mouthful, which is why I just abbreviate it as CPCTC. Corresponding parts of congruent triangles are congruent. Hence why I use the abbreviation, because that's a mouthful. Okay? So what that is saying is that if 2 triangles are congruent, then each pair of corresponding sides and angles are congruent. Okay? So what that means is each pair that matches are congruent to each other. Okay? So for example, let's look at our angles. Alright? I have angle A. Okay? Which angle in the other triangle, based on those arcs, is congruent to angle A? D. Okay? Notice they have one arc. Okay? So that means those are congruent to each other. So angle A and angle D are congruent to each other. Okay? Which angle is congruent to angle B? Say it again. E. Okay. E. Yes. So B and E are congruent to each other. Because they have those 2 arcs. And then what's congruent to angle C? F. Because they have 3 arcs. Yes. Okay, so that's my angles. Now I need to do the exact same thing for my sides. Okay? So, and you also have to be very careful with how you word it. Okay? So let's look at side AB. Okay? Side AB has 1 tick mark. But notice since I started from A with that has 1 arc, I got to start with that same thing on the other side. Okay? So which side is congruent to side AB? DE, yes, DE. Okay. So AB, I started with 1 arc and moved to the 2 arcs. So it had 1 tick mark, and then the way to name it is start with the 1 arc and go to the 2nd arc. So AB, side AB is congruent to side DE. Okay, so AB and DE are congruent to each other. Which side is congruent to BC? EF, good, EF. Okay, so BC, I started with 2 arcs, and I got to go to the side that has the 2 tick marks and start with the 2 arcs. So that would be EF. And then lastly, scroll down just a smidge. AC is congruent to what? DF, good. AC and DF are congruent to each other. Alright, so now that I've listed all the corresponding parts, I can say that triangle ABC is congruent to triangle DEF. F. So triangle ABC is congruent to triangle DEF. And notice how I wrote this, and I can, based off this, I can also figure out all this. Okay? I said that angle A was congruent to angle D. A and D are the first letters in that phrase that I'm saying they're congruent. So they're going to be congruent to each other. B and E are the second letters. They're going to be congruent to each other. C and F are the third letters. You see where I'm going? Because of their position in the way that I worded it, they're congruent to each other. A, B are my first 2 letters. That's congruent to my first 2 letters over here, D, E. So on and so forth. Okay? So if you have the name and no markings in the picture, you can still figure all of that out. Okay? Just based on the way the letters are positioned in your congruent statement. Okay? So that's one of the most important things, is being able to determine how are these figures congruent based on the name. Okay? Now let's talk about our congruence theorems. Okay, the first one is called side angle side, or SAS. Okay? If two sides and the included angle, okay, really quickly, included angle, if you need to write it down, is the angle in between the sides. Okay, an included angle, if you need to write that down, an included angle is the angle in between the sides. Okay, one more time. An included angle is the angle between the two sides. Okay? So if two sides and the included angles of one triangle is congruent to two sides and the included angles of another triangle, then the two triangles are congruent by side angle side. Okay? So let's look at this picture right here. Okay, let's just go in order. Side, angle, side. If I look at side ST, be careful how you do this. Name it correctly. Which side is congruent to side ST? YZ. Good. Okay, notice I started with the angle. That's got the one arc. I got to start with the same thing over here, and then they both have one tick mark. So YZ. Perfect. So that's one side. Okay, this one should be real easy. Angle S is congruent to what? Y. Good. So angle S and angle Y are congruent to each other. And then, let's see. Side RS is congruent to what side? X, Y. Good. So I started with the non-angle, and I went to the angle. So I got to do the same thing here. X, Y. Okay. So based on how I worded that, I can say the angle or triangle RST is congruent to triangle XYZ. And I can see that makes sense based on what I just came up with. ST are the last two letters. Y means the last two letters. S is in the middle, Y is in the middle. So even if you switched it around, say you said STR, it would just have to be that exact same thing on the other side. They've got to match. The corresponding parts have to match. Okay? Alright? And then the last congruence theorem that we'll talk about today, at least, is side, side, side. That one's pretty straightforward, hence the name. So if three sides of one triangle are congruent to three sides of another triangle, then the two triangles are congruent. Okay, so very quickly, let's just list our sides. Okay? Side AB is congruent to what? DE. Okay? Notice, I don't have any angles to work with, but notice that I started with A, and A is between that one tick mark and those three tick marks. So I need to start on the same side over here. So that would be D, and then E. Good. Okay. What about BC? What side is BC congruent to? There you go, EF. Good. EF. And then AC. What side is AC congruent to? There you go, DF. Good. So because of that, I can say that triangle ABC is congruent to triangle DEF. Okay? It doesn't necessarily have to be in alphabetical order. Your parts just have to match. Okay, so I could have said BCA, but on this side, if I said BCA, I would have had to say EFD. So it doesn't necessarily have to be alphabetical order. Your parts just have to match. Okay? Alright, for these first few problems, we're just listing the corresponding parts of the congruent triangles. So we're given the name, we need to list the corresponding parts and angles and then label it in the picture. Alright, so let's start off with the angles. I think the angles are easier. So based off the name, which angle is congruent to angle A? X, good, okay? It's gonna get real messy on mine, so I'm not gonna do it. In your picture, put one arc for angle A and angle X. Like this. Say that those are congruent, okay? I'm not gonna keep going with this because as you can see, my picture's a little small. It's gonna get messy real fast. Okay, so A and X are congruent. Angle A is congruent to angle X. Alright? What about B? Y, good, okay? Second letter listed. So have two arcs for B and Y. And the reason you gotta have two arcs is because we're saying that these are congruent to each other, but they're not congruent to A and X. Okay? So angle B is congruent to angle Y. And then that leaves me with what? C and D. So for that one, you'll put three arcs. Say that those two angles are congruent to each other. Okay? Alright, now let's talk about our sides. Okay? What side is congruent to side AB? XY. Okay, AB was the first two letters, and the next one, XY, is the first two letters. So AB and XY. So on your picture, you'll put one tick mark. Alright. What side is congruent to side BC? YZ. Second and third letter in the other one. So let's see, YZ and BC have two tick marks. And then that leaves AC being congruent to XZ. Very good. So AC and XZ are congruent to each other. You'll have those three tick marks. Alright? All good on that? It's very important that you can identify those and label them correctly, okay? Alright. This next one's a little more tricky, but we can handle it. Okay? I think this one is easier to start off with our sides. Okay? So let's start off with our sides. Side BC. What is it congruent to? DE, good. Okay, BC and DE are congruent to each other. The first two letters. Alright. Side CD is congruent to what? EB, good. So CB and EB are congruent to each other. And then side BD is congruent to what? DB. Okay, but that so happens to be itself. Okay, we'll talk about, that's called the reflexive property, when something's congruent to itself, so like a side is congruent to itself. We'll talk more about that on the back. So side BD, BD, and DB are congruent to itself. Alright, now let's talk about the angles. And we're going to be a little careful here because we got to name these correctly. Okay? Let's see. Let's start off easy. Let's start off with angle C. What is angle C congruent to? E. Okay? C and E are congruent to each other. They're both the second letter. Okay? I cannot keep going with this because of this line right here. So notice that B and D are not a whole angle. We don't know if they're cut in half. We just know that this is going through those angles. Okay, so I can't keep going with this. But I can figure this out. Okay? This angle right here. So this left one. Here, let me redraw that. This angle right here. Okay? How can I name that? Repeat that.
CDD.
No. Second lower one. CDB. Okay? That's my vertex. Okay? Or you could say BBC. Either or. So let's just do what Laura listed. Angle CDB. Okay? CD is the middle. B. So this angle right here. Does that make more sense? Oh, I thought you said CB. I could have just misheard you. Okay? Now I need to look at the other triangle, follow the order of these letters, and see what matches here. Okay? So C is my second letter. So what do I need first? E. Then what? What letter is D in my name? So I need B next, yes, right? D's the third, so I need B. And then what do I need last? D. Okay, so that is E, B, D. So that's this angle right here. So those are congruent. And then if I do the other two angles, so if I do this bottom one right here, how can I name that? This angle right here. How can I name it? EBD, that works. Okay, EBD. EBD. Okay, B has to be in the middle. Okay, and then let's look at our name carefully. I started off with E. So what do I need to start off with for the other one? C. Then what? Hold on, I'm doing this. E, B, C. What'd you say, Nick? I've already got C. D, there you go. Okay, so D is the third letter. So that means I need the third letter over here, which is D. And then what? B. So C, D, B. Okay. So having that name right and being able to look at the pieces is really important. Okay. Are there any questions on those? Being able to figure out those congruent parts. Just take your time with it. It can be a little overwhelming, but just read the letters slowly and take your time. Okay. All right, let's continue. For these next four, I'm asked to label the pairs of triangles as congruent by side, 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 angle, side, or neither. Okay, it can be neither. All right, so number 3. Are they congruent by side, 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 angle, side, or neither? Side, 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 good. I've got 1 tick mark, 2 tick marks, 3 tick marks. So this is congruent by side, side, side. All right, number 4. Side, 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 angle, side, or neither? Okay, go look at the definition of side, angle, side. Where does that angle need to be? In between. Okay? Is that angle in between the two sides? No. Okay? If it were side, angle, side, I would need my angle right here. Okay? So just because I have two sides at an angle does not mean it's side, angle, side. If for it to be side, angle, side, that angle must be in between. So because it's not in between, what's my answer? Neither. Okay? That would be neither. Alright, what's number 5 then? That's side, angle, side. Okay, because that angle is in between the two sides. Alright, so that's side angle side. What about number 6? Neither. Okay? Haley Murs, tell me why neither.
Because one of them only has one difference and the other one has two.
Perfect. Okay, so these sides, or that angle is in between the sides, but all this is saying is that these two sides are congruent to each other, and these two sides are congruent to each other. It's not saying anything about the triangles being congruent to each other. So like notice for this one, I have one tick mark on one triangle, one tick mark on the other triangle. I don't have that here. I have my one tick marks on one triangle, and I have my two tick marks on the other triangle. So that's just saying that these sides are congruent to themselves, not that the triangles are congruent to each other. So perfect, number 6 is neither. Very good. Right? For some reason, this came out wrong on your paper, so number 7 is the one to the left. I don't know why it came out that way, sorry. So number 7 is the one to the left, and number 8 is the one to the right. So if you need to write that down. Okay, so for these two problems, I'm asked what additional information is needed to show that the triangles are congruent by whatever. Okay, so for example, for number 7, I'm trying to show that these two triangles are congruent by side angle side. Okay, I have a side, I have an angle, I need another side, right? So I need to figure out what two sides I need to be congruent to each other. Perfect. AC and DF. Okay, so remember the angle needs to be in between the sides. So that gets me here, and then I need to make sure I name that correctly. So if I name the first one side AC, I started off with the angle, I need to start off with the angle over here. So I need for those to be congruent to each other. And if those are congruent to each other, then I can say that those triangles are congruent by side angles. Alright, number 8. I need to show that these triangles are congruent by side, side, side. Okay, sometimes with these problems, well, let me explain this. Okay, with these problems, there's only one piece that's missing. Okay, there may be a piece that's missing to you, but it should be obvious. Okay. You need RQ and YQ, okay? Let's talk about QS real quick. Do I have that QS is congruent to something? It's the same thing, right, for both triangles? Okay, so QS is congruent to itself. Okay, so that's supposed to be your obvious. Okay, and that'll become more obvious as we practice. Okay? QS is the same for both triangles. So QS is congruent to itself. So I'm supposed to know that. Okay? And like I said, with practice, you'll be able to recognize that really easily. So QS is congruent to itself. So Nate, tell me again, what's the piece that I need? RQ and YQ, very good. Okay? So I need that for RQ, and you named it perfectly. I need RQ and YQ to be congruent to each other in order for this to be side, side, side. Okay? I'm supposed to know based off that picture that since QS is the same for both triangles, that QS is congruent to itself. So the piece that I really need are those two sides, RQ and YQ, to be congruent. Okay? So anytime with these problems, if you see it on your homework, yes, it's on your homework, and it'll for sure be on your test. I'll tell you that right now. It'll for sure be on your test. You're only missing one piece. Okay, so if it looks like you're missing two pieces, one of them is obvious. But like I said, with practice, you'll be able to tell. Okay? All right, are there any questions on the front before we flip to the back? All right, let's flip to the back. Okay, here's where things get fun. Not really. Alright, with triangle congruence, as you've seen already, we haven't dealt with any numbers, right? And for probably 90% of these problems, we're not. Okay? We have to do something called proof. Okay, and proving, not to scare you, but proving is a good bit of writing. Okay, not like paragraphs. But we need to show that these triangles are congruent by, it's essentially kind of like a puzzle. We're putting the puzzle pieces together, and what we have to do is you have to state that, certain angles or certain sides are congruent to each other, but then you have to tell me why they're congruent. Okay? So we have to work our way through until we have all of our pieces, and then say that these triangles are congruent to each other by whatever. Okay? I promise it's not as bad as it seems, but it is a little bit of writing. Okay? But what I want to emphasize is if you have a question, please ask. Okay? Because it's not like we're just going and solving an equation here. Okay? We're explaining ourselves. Okay? So you got to be able to explain yourself. So if you're not understanding something, please, please, please ask. Okay? So let's start off with number 1. I am asked to prove that the triangles are congruent by either side angle side or side side side. And I am given that point P is the midpoint of lines JK and LM. The first part of a proof is to write out your given. Okay? Even though it already says it. Alright, so that's what we're going to do. The first thing you need to write is that we're simply just going to rewrite the statement. P is the midpoint of JK and LM. So here you write your reason, or here you write what you're showing, and then beside it, you tell me how you know that, or why you know that. Okay? And the reason I know that, well, I was given that. So I say, I was given that information. So that's the very first step of a proof. Always write down your givens. Sometimes there can be multiple givens. Okay, but always write down what you're given first. So I was told P is the midpoint of JK and LM. How do I know that? I was given that. Alright, now I need to put the puzzle pieces together. So let's talk about what that statement means. Point P is the midpoint of JK. Let's stop there. Point P is the midpoint of JK. What is that telling me? What does a midpoint do? Splits it in half. Okay? A midpoint splits a line or a segment in half. So what does that mean about these two parts? Yes. Okay? So a midpoint splits a segment in half. So if the segment is being split in half, that means those two halves have to be equal to each other. Okay? So if I know that P is the midpoint of JK, that means those two segments are congruent to each other, because that point P is splitting that in half. Okay, so that's the next thing I'm going to say. JP is congruent to what? How do I say that next one? KP. So JP and KP are congruent to each other. And how do I know that? We're just going to say definition of midpoint. By the definition of midpoint, I can say that those two segments are congruent to each other. Okay, so I've got a side. Good start. We're getting somewhere. Alright, let's keep going with that given statement. So we talked about point P is the midpoint of JK. Point P is also the midpoint of LM. What is that telling me? LP and MP are the same. Good, okay? Point P is the midpoint of this part. So those are going to be congruent to each other because point P is cutting that in half. Okay? So LP and MP are congruent to each other, once again by the definition of midpoint. Alright, I've got two sides. Awesome. We're getting somewhere. Alright, so now let me ask you this. So now we got to start thinking, well, is this going to be side, 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 or side, angle, side? Is there anything in this problem that can help me figure out that JM and LK are congruent to each other? Was I given anything that can help me there? No. Okay? And we're not grasping for straws here, okay? If there wasn't anything given there that could help me, then that's it, okay? So, sounds like it's not going to be side, side, side. So now I need to figure out an angle. Thoughts on an angle? That could be congruent. Tell me why. Very good, very good. They're vertical. Okay? Notice, I have intersecting lines. Opposite angles are congruent. Okay? So I can say, how did I say it on here? Yeah, exactly how you said it. Angle JPM is congruent to LPK. And I can say, because they're vertical. Just like Callie said, perfect. Vertical is going to come up a lot. Okay, vertical and supplementary. That's going to come up over and over and over again. Okay, so let me ask you this. Do I have a side? Yes. Do I have an angle in between the two sides? Yes. So how are these triangles congruent? Side, angle, side. Good. SAS. So now that I've said all that, I've stated each thing. I listed my givens. I talked about the two sides. I talked about the angle. I can now say that triangle JPM, we'll just word it exactly like this, JPM and LPK are congruent by side, angle, side. And one notation to say that, hey, I've said what I've said, I'm done, is a box, and you can either just put an X in it, or you can color it in real fast. So that box is just saying, I've said what I've said, I'm done, that's it. Okay, I want to stop there and ask if there are any questions. Is it making sense? What's happening, maybe? Just a lot of writing. You really gotta, like a puzzle, you gotta put the puzzle pieces together, okay? But please stop me if you're confused or if I'm going too fast or anything like that, okay? Because this can be overwhelming. Alright, before we talk about number 2, let's give a definition for reflexive property. Okay, so I simply just put this on the top of the back page. So the definition of reflexive property. Right, reflexive, not reflective. Alright, with an X. So reflexive property is just saying that a line segment, angle, or shape that is congruent to itself. So just like what we talked about on the front on number 8, that segment QS was congruent to itself because it was the same thing for both triangles. So reflexive property is saying that a line segment, angle, or shape is congruent to itself. Okay, so reflexive property is a reason that you can use for a lot of this, okay? Alright, now let's work on number 2. Alright, I am asked to prove that the triangles are congruent by side, 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 or side, angle, side, and I'm given that H is the midpoint of GJ. What is the very first step in a proof? Write down what? Write down your givens. Okay, write down your givens. So H is the midpoint of GJ. How do I know that? I was given that. Write down your givens first. If you cannot do anything else, you can write down your givens. Alright. Anything else I was given? GI and J are congruent. Okay, so it didn't specifically state it, but notice I've got tick marks. Okay, so the picture's already telling me that those are congruent. Okay? So GI and JI are congruent, also because I was given that. Alright? Now I gotta figure out puzzle pieces. Alright, let's start off with what I was given. H is the midpoint of GJ. What is that telling me? GH and JH are the same. Yes. Okay. H is the midpoint. So that means it's cutting GJ in half. So those two sides are congruent to each other. Okay, because H is cutting that segment GJ in half. Alright. So GH and JH are congruent to each other. What would my reason be? Definition of midpoint. Okay, definition of midpoint. Exactly. Definition of midpoint. Alright, so I've got two sides. Can I figure out an angle based off what I'm given? So remember, the angle needs to be in between the two sides. So if I were to figure out an angle, it would need to be G and J. Is there anything telling me anything about G and J, those angles? No. Okay. So I need to figure out a side. HI. Okay? So just like that problem on the front, notice that HI is the same for both triangles, right? If I take those triangles and split it apart, they both have HI as a side. Okay? So I can say that HI is congruent to itself. And then what will my reason be? Reflexive property. There you go. So same segment for both sides of the shape. So I would say that HI is congruent to itself by the reflexive property. Very good. So have I explained each side? Yes. Okay. So now, if I name this first triangle, let's see, if I name it as GHJ, the triangle GHJ, how do I name the other triangle? JHI. Good. So, oh wait, I did not do that right. I'm sorry. GHI, I'm sorry. GHI. So GHI is congruent to JHI. Okay? You could have worded that a different way. You just got to be sure you're consistent. Okay? So JHI, triangle JHI. And how are they congruent? Side, side, side. And then be sure you have your little box, whether you put a X in the middle or color it in, whatever, to signify you're done. Alright? Questions on that one? Alright, let's move on to number 3. Number 3, we'll be able to do really quick, but we still have to write a few things out. Okay? I need to show that HGF is congruent to JKL, and I'm given that Y is 7. Okay? So what I'm simply going to do is just plug in Y over here, make sure they match, write out a few things, and call it a day. Okay? So y is 7, y plus 6. What's going to make that side be? 13. 7 plus 6 is 13. So this side is 13. I'm just plugging in 7 for y, guys. That's all I'm doing. Okay. 5 times 7 is what? 35 plus 5? 40. So this angle's 40 degrees. And then 4 times 7? 28 minus 1? 27. Interesting. Everything matches. Right? That's what was supposed to happen. Alright? So, side GF. Now we're just going to write out which sides are congruent to what. Okay? Side GF is congruent to what side? KL. So the angle was listed second. So KL. Okay? Angle F is congruent to angle L. They're both 40 degrees. And side HF, someone other than Nate, what side is HF congruent to? JF, very good. So I can say that AGF, or HGF, is congruent to JKL by side, 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 or side, angle, side? Side, angle, side. Okay, I've got that angle in between. All right, side, angle, side. Not for this one. Not for this one. By going and plugging in y, that was all I needed to do for that one. You don't have to do any explaining. All right. Pretty easy, not too bad. 2 more problems. And then your homework for this weekend will be on paper, just because the proofs. Delta Math has proofs, but I don't really like the way they're structured. I think it's a little confusing. So, but your homework's only 8 problems. So. Alright. Number 4. Okay. I am given that RT is a perpendicular bisector. Okay? We haven't talked about that in a long time. Okay? What does perpendicular mean? Perpendicular. Okay, think about perpendicular slopes. What happened? Okay, yeah. They cross. Okay, so you're right, Kaylee. Okay, so they cross. And then, at what type of angle? 90. Okay? And then, let's see if anyone remembers this. Anyone remember what bisect means? Okay, bisect means it cuts it in half. Okay, write that down. Bisect cuts in half. So perpendicular bisector cuts the segment in half and it intersects it at a 90-degree angle. Okay? That's what a perpendicular bisector is. It cuts the segment in half at a 90-degree angle. Okay? So, what's the first thing I need to do in a proof? State your givens. Okay, so that's what I was given. Given that RT is the perpendicular bisector. And I was given that. Start off there. RT is the perpendicular bisector. Okay. So perpendicular bisector means it intersects at a 90-degree angle and it cuts the segment in half. Okay? So this is saying RT is cutting this segment in half. So what does that mean about these two sides? They equal each other. Okay, so it's kind of like a midpoint. Okay? This perpendicular bisector is cutting it in half. Oops. So those two sides are equal to each other. Okay, we'll deal with the math in a second. We gotta prove these triangles are congruent first. So, which side is congruent to WT? ST. Okay, WT and ST are congruent to each other. And we'll say by definition of perpendicular bisector. Kind of like definition of midpoint. Remember that the symbol for perpendicular is that upside down T. So if you ever see that, that means perpendicular. Just to abbreviate. Okay. Down the side. Now I gotta figure out the rest. Okay. Yeah, tell me why. Uh-huh. So what's gonna be your reason? There you go. Okay? If I break these two triangles apart, RT is a part of both of them, right? Okay? So I can say that RT is congruent to itself by the reflexive property. If anything's congruent to itself, it's reflexive. Alright, so RT is congruent to itself by the reflexive property. Okay. So let's think about, before we get there, I need to decide at this point if it's going to be side, 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 or side, angle, side. Is there anything telling me that RW and RS are going to be congruent to each other? No. Okay. Nothing in here is telling me that those can be congruent to each other, which means I need to find an angle. Okay. Nate is saying that this angle right here is 90 degrees. Okay. Tell me why. Uh-huh. So you could say because by definition of perpendicular bisector, I think Addison, you were going somewhere else. Okay, what do I have right here? A line. Okay, so you could say supplementary, definition of perpendicular bisector, choice is yours. Okay, I'm just going to say supplementary. That's the first thing that came to my mind. But if you put definition of perpendicular bisector, you can say that as well. So if I name this first angle as angle WTR, or not triangle, angle, how would I name the other angle? STR. So WTR and STR are congruent. I'm going to say by supplementary, you can say definition of perpendicular bisector, whichever one came to your mind first. So to me, I saw the line. So I'm going to say supplementary. Let's say this were a question on your test. If you said definition of perpendicular bisector, that's still correct. So sometimes there are multiple reasons. You just got to choose the one that makes sense to you. Alright, so let's double check. Do I have a side or do I have two sides? Yes. Do I have the angle in between? Yes. Okay, so now that I have that, I can say that these two triangles are congruent by side angle side. Yes, SAS. Let's be congruent by side angle side. Alright, and then if you look at the instructions real fast, I was also asked to find ST, so just the length of it. Okay, so what was I told, or what did I mention about WT and ST? They're equal. Okay, so to figure out the length of ST, just simply set those two pieces equal to each other and solve for x. Okay, so real quickly, just do a little bit of math real fast. 4x minus 1 equals 3x plus 2. I said in my proof that WT and ST were congruent to each other by the definition of a perpendicular bisector. Okay. So when I solve for x, someone tell me what they would do first. Bring over the 1. Okay, that works. Bring over the 1. So that gets me 4x equals 3x plus 3. And then what? Subtract 3x. So 1x is 3. So x is just 3. And if I go plug that into ST, ST was 3x minus 2. So 3 times 3 minus 2 is, or plus 2, I'm sorry, plus 2 is 11, yes. So ST is 11. All right, any questions before we do this last problem? All right, let's do it. All right, for this last problem, I am given that GH and GB are congruent to each other. GH and JB, or GB, those are congruent to each other. And I'm also given that angle HGF. So HGF is right here. And angle BGF, which is right here, those are congruent to each other. And I'm asked to prove that angle H and angle B are congruent. But before we do that, let's just prove that the triangles are congruent. Okay? First step of a proof is state your givens. Okay, so I was given that GH and GB are congruent to each other. And I was given that angle HGF and angle BGF are congruent to each other. Alright. So that's my givens. What else can I say? Not me. My givens are done. Okay, let me ask you this. I've got a side and an angle, so this must mean it's side, angle, side, right? It can't be side, 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 so that means I need another side. GF is congruent to what? 5. Good, okay? GF is used for both triangles. So it's going to be congruent to itself by the reflexive property. Good. GF is congruent to itself. Anytime you see a part that's with both triangles, it's got to be congruent to itself. Okay? So, have I proved that it's side, angle, side? Yes. Okay, so let's write that out real fast. So triangle HGF is congruent to triangle BGF by side, angle, side. Okay. But, does the question ask me to prove that the triangles are congruent? No. Okay, it asked me to prove that H and B are congruent. Okay. Anytime you have a proof and it says prove that some of the parts are congruent, that's where you're going to use that thing we talked about on the very first thing on the front page, that CPCTC. Because I've said that these triangles are congruent, now I can say that the corresponding parts are congruent. Okay? So are H and B corresponding parts? Angle H and angle B? Yes, they're in the same position. Okay, and if you look at the name as well, H is listed first, B is listed first. So I can simply just say that they're congruent to each other by the CPCTC. Corresponding parts of congruent triangles are congruent. And that is actually the end of my proof. So anytime your instructions say prove that the sides are congruent or prove an angle is congruent, you have to end with the CPCTC. Okay? After you've shown the triangles are congruent. Because once you show the triangles are congruent, you can say that the corresponding parts of the triangles are congruent. Okay? Alright, I know that was a lot. Yeah, Nate. Yes. Yes, absolutely. I know that was a lot. I appreciate you sticking with me. Are there any questions at all? Alright, I'm going to go ahead and give you your homework. You've got 20-ish minutes. Definitely start it. It is 8 questions. There are 3 proofs, 2 listing corresponding parts, and then 3 finding the missing information to show that they're congruent. Okay? Have your notes out of what it's there for. And then since this is paper, this is due Monday. Okay? Not due day test, due Monday. Alright? If you have questions while you're working on it, ask. And then once you're finished with it, you can submit it on Schoology or show it to me in class Monday morning. But it is due Monday because it's paper and we gotta go over it. Okay?